welcome friends to my YouTube channel. Now on today's lecture I shall going to start a new chapter, that is surface tension. Surface tension. Okay. Now first question that arises, what is surface tension? Okay. Now you all know that a free surface of a liquid almost behaves like a stretched elastic membrane and tends to contract to the smallest possible area. Okay, you all know it that free surface always behaves like a stretched elastic membrane. Okay, free surface of a liquid behaves like a stretched elastic membrane and tends to contract to the smallest possible area. Okay, this thing you know. Now another thing that you all know, that for a given volume a sphere has least area. Okay, among all objects, among all figures. Okay, for a given volume a sphere possesses least area, and this is the reason that the liquid drops attain spherical shape. Okay, for a given volume a sphere has least area. For this reason liquid drops attain spherical shape. Okay, because a sphere possesses least area for a given volume, so this is the reason. That's why the liquid drops are spherical in shapes. Just take an example, the raindrops and the mercury globules all are spherical in nature. Okay, so this is the reason for which the raindrops and mercury globules are. This is the reason for which the raindrops are spherical, or you can say the mercury globules are also spherical. Okay, fine. Now before defining the surface tension, one thing that we have to know that what are different force of attraction between the liquid molecules. Okay, now there are two type of forces. Okay, that is, if we categorize the forces, one is cohesive and another is adhesive. One is cohesive force of attraction and another is adhesive force of attraction. So let us define this, then we will be able to define the surface tension. Okay, now first of all, what is cohesive force? What is cohesive force? That is the force between same type of molecules. Same type of liquid molecules are known as cohesive force. Suppose this is one water molecule and this is another water molecule. This molecule gives a force on that one and this molecule also gives a force on that one. So these are same type of molecule. So So the force of attraction between the same type of molecule is cohesive. Say this is water, or you can say this is mercury and also this is mercury. Okay, so the force between same type of force of attraction between the same type of molecules. Okay, force of attraction between same type of molecules are called cohesive force. Okay, the force of attraction between the same type of molecules are called cohesive force. Fine. Now just take another example. Say this is a water molecule and this is mercury molecule, and again both the molecules possesses force of attraction to each other, but here the molecules are different. One is water and another is Hg. So this type of attraction is known as adhesive force. Okay. Adhesive, that is force of attraction between different molecules are called adhesive force. For example, say mercury water. Okay, so these are two different type of forces between the liquid molecules. Okay, now we can easily define the term surface tension. Okay, how we can define the surface tension? Okay, say this is a liquid molecule. Okay, we draw an imaginary line on the molecule. Okay, now these molecules attract these molecules and these molecules will attract these molecules. Okay, so molecules of left hand side will attract the molecules of right hand side, and similarly the molecules of right hand side will attract the molecules of left hand side. Okay, no problem. So surface tension is actually the force per unit length that is acting on both sides of an imaginary line. This is the imaginary line and this force acts on both sides. So force per unit length acting on both sides of an imaginary line that is drawn on the liquid surface. Okay, and the direction of force is always perpendicular to the line, because this is the line and this is the force. This angle is always 90 degree. Okay, the direction of this force is always perpendicular to the imaginary line. Okay, and surface tension is usually the force per unit length which acts on both sides of the imaginary line that is drawn on the liquid surface. Okay, okay, so because the molecules of this side will attract the molecules of this side and also vice versa, so obviously there is a force of attraction. So if there is a force, then there will be a term force per unit length. So surface tension is that force per unit length that acts on both sides of the imaginary line. Okay, and the direction of this force is always perpendicular to the imaginary line. Okay, surface tension is defined as the force per unit length acting on both sides of an imaginary line drawn on the liquid surface. Okay, the direction of force is perpendicular to the imaginary line, or you can say tangent to the surface, or tangent to the surface. Okay, fine. This is the surface. So perpendicular to the imaginary line and tangent to the surface. So obviously surface tension we always denote it by S, and on some books it is always denoted by T. So both are true, but I always denote it by S since I denote T as temperature. Okay, so I will use capital S. Okay, so surface tension is the force per unit length. Okay, so surface tension is the force per unit length acting on either side of the imaginary line drawn on the liquid surface. Okay, and the direction of force is always perpendicular to the imaginary line. And also you remember one thing that is very very important, that surface property of a liquid is totally different than the bulk property. Remind this thing. Okay, here we are talking about the surface property. Okay, surface tension means surface property. Okay, surface tension is a surface property which is different, which is totally different from bulk property. Okay, which is totally different from bulk property. Remember this thing. So surface tension we usually define this by this. So what would be its unit? The dimension. This is the dimension of force and this is the dimension of length. So the dimension of surface tension is mt to the power minus 2. Okay, and what is its unit? Newton per meter. SI unit is Newton per meter, or CGS unit is dyne per centimeter. Okay, for common liquid like water, what will be the surface tension? We all know that is bar 72 dyne per centimeter. Okay, for water surface tension is always 72 dyne per centimeter. Okay, so in today's lecture we shall discuss about the introduction of surface tension. At first we define why a liquid drop attains spherical shape. Then we have introduced the concept of cohesive and adhesive forces, and then we define surface tension, which is a surface property of a liquid, and the bulk property is totally different than the surface property. Okay, now in our next class I will discuss about the surface energy, okay, and other issues. Okay, so dear guys, if you don't subscribe my channel, then kindly subscribe it to get latest videos. Okay, thank you.